Hello everyone, welcome to the first day's course of Supermap SMC 5D application analysis. Today we are going to learn about vector analysis. In our reality life, you may want to know where is the nearest hospital, school, or market to you. Today we are going to find the hospitals and to see if the hospital distribution is reasonable. I think all of you have already prepared a desktop and your country's data. So now let's begin. Firstly, we will use the hospital data, the POI data of hospital, and the administrative area data, and the building data and population data. These four data. Firstly, yesterday we already import. Yesterday we already import this data. Here includes the administrative data and the POI data. So the hospital data is included by the POI data. So we need to we need to select the hospital data from the whole POI data, and the next is the building data. We are going to use the building data to see where is the building areas in our city. And the next is the population data. We are going to use the population distribution to see if the buildings or the hospitals distribution are reasonable. So now let's first we will divide three parts. First part is data processing. We first process this data, and then we are going to analyze this data, and finally we will get the results. So let's first do the processing of data. Here I will take Russia as an example region in the following course. But I wish you can find your own city to do the task. Here is the introduction of Russia, and it is a major urban, commercial, and educational center of Bangladesh. So the first step is to get data of this region. Here, this picture shows the Russia's whole area and all the cities of Russia. So the first, let's first open the. Yesterday I introduced the administration 0 to 3 data. So here we first and the administration 1 data into the new map. So here it is the whole country's data, and which one is Russia? Here we can open the attribute table to find we find this Russia is here. It highlights in the map and here, so we can simply right click here and export, just save as data set. We'll keep all these attributes or fields, and then here we're going to we new data source to store the Russia's data. Here I mean Russia, like this, and then let's save it as a new data set. And here I made it Russia, and the data source as next to the new data source. And okay, here we can end to count map. So we extract the Russia's region, and then we are going to use this boundary data to extract the POI data, building data, and population data. Firstly, let's first find the hospital data. Also, you can extract the school. You can extract the school data or supermarket or anyone you are interested in. So here, for this course, we just take hospital as an example. Here we can open it to count map, and we can see it is the whole data of Bangladesh. So we only need the data in Russia. So here I want to introduce the vector analysis in Supermap. Let's first see the help document. If you download the whole the installation package, you will get the help document, and here is the introduction of all this technical knowledge. So here we can see the spatial analysis. The first one is vector analysis. Here we can see it includes buffer analysis, overlay analysis, and dynamic segmentation. Let's first take a look at buffer analysis. So we know a buffer analysis is a process of forming polygon entities with certain extents around a group or a type of map features according to a specified distance condition. Here we can use the point buffer, line buffer, region buffer, or multi-buffer analysis. So this is buffer, and the next is overlay analysis. The overlay analysis is one of the basic GIS spatial operations. It is a process of generating new data through set operations on vector data sets. Includes clip, union, erase, intersect, and so on. Let's see these operators. Here we can simply know about this. What is contained interaction. Here is the introduction for details. So you can view this here. And the next is the Approximate analysis, Tyson polygon construction. We know that Tyson polygon is also called Voronoi diagram, and it has these properties. Every Tyson polygon contains only one discrete point, and for any location in a Tyson polygon, the discrete point associated with that polygon is the closest one among all the discrete points. And the third one is the points located on a side of a Titan polygon have equal distance to the two discrete points defining that side. Now here shows the how to construct the Titan polygon from polygon to the polygon. So in this course we are going to use Titan polygon to find where is the nearest hospital to you. Just like the picture shows, each polygon only contains one point. Just like we suggest, this point is a hospital. If you are in this area, so the nearest hospital is this one. But if you are in the just like the green region, the nearest hospital is this one. So this is about the Titan polygon, and the next is distance calculation. Here we can find the two. We can calculate the 2 points distance, and we can find the nearest position from you. Just like if you are in a school, you want to know where is your nearest hospital, you can use this distance calculation to calculate calculate the distance of all the hospitals from you, and the results will return you the nearest one. So that is distance calculation. And also SuperMap also includes many data processing methods for the vector data set: dissolve, osmose, or extract borderline, and like this. Let's see these functions in desktop. The first is the analysis, vector analysis. Here we can find the analysis menu, and under the analysis menu here, vector analysis, query, vicinity network, and vector analysis. Here is buffer analysis, overlay analysis, and proximity analysis. And the processing method of the vector analysis, we can find it under the data menu. And the data processing, here we can see for vector processing, here include append row, append column, and also aggregate points, such like these methods for vector analysis. So now the first we are going to extract the POI of hospital in Russia. So here let's think about the first condition is the hospital. The first condition is the point the POI is in the Russia region. And the second condition is that we only want to the hospital data. So here we need to judge the first judge the spatial relationship between Rajai, and then we will set a condition to select hospital from all the POI data. So here we can use the analysis of spatial query. Let's first select select the research region, this area, and then we find the spatial query. Spatial query is a method to judge the spatial relationship between two or more spatial data sets. So here we can see the searching layer which already says Rajai, and here we are going to find the POI in the Rajai. So here we are going to set the query condition. Here we can see there is contain, disjoint, intersect, and touch. So here we want to the POI contained by Rajai. So here we contain, and here is the instruction of this operator. It will return objects in this search layer contained by the searching object. So here we already set the first condition in the Rajai, and then we are going to select a hospital from the POI. So here we are going to add the attribute query condition. Here we can click here, and here we can see there is 3 point. Here we can click it, and we can set the circle expression here. Then we are going to find the F class. And here we can see get unique value. We can see all these values contained by the F class. So here we can find the hospital. Here, this one hospital. So we are going to only select the hospital of the POI. Then we just check this one. We only need to calculate the POI data, and then we want to save these results. We save it to the new research, and the name we rename it hospital. I don't know what. Okay, just query. Here we can see all this is the hospital selected. The next here we can I didn't save it, right? Let's do it again. Analysis, spatial query. First, I set the spatial contain and set the circle expression F class equal hospital. Double click it, and then it will add to the expression. Okay, and save it as Josh. Hospital, yes, and query. So here we can see there is a new dataset hospital generated. And then let's add this hospital to current map. Here we can see it's only in the Rajshahi region, and we can open the attribute. We can see efficacy, or hospital, and here is their names. And then the next we are going to extract the buildings. Yesterday I said there are more than 5 million buildings in Bangladesh. So here we don't open it, and here we are going to use the overlay analysis to extract the building. Here we can click the overlay analysis. We finish the research and get hospital POI. Here the special query condition with set contain, and query condition of course equal hospital, and then we are going to get the building of the city. Here we can over analysis. We use clip. The clip. Let's see what is clip. Here we are going to find the vector analysis clip. So here we can see layer clipping is a process of extracting feature parts from a source dataset using an overlay dataset. I think here is the clip algorithms. We also can understand that we are going to use this Rajshahi boundary to cut the buildings, and then we will get the buildings only in this region. So the source data, we are going to use the buildings. Here is we are going to get buildings in Rajshahi. So the overlay dataset, we are going to use the Rajshahi, and then we save the result to the new data source, and the name is building. And here we keep the tolerance as default, and then we click OK. It also needs some time to process it, because the building data is really large. Please just be patient if you found your desktop cannot be moved. It is because of the large number of the data. I think I didn't use par before, so it take much more time, and now I connect my par. Let's continue to wait 2 minutes. If it is still not running, and I think I need to do it again. It should not take much time, so I think it's because I didn't use the laptop power before. And the next, we will get the population distribution data of Russia. I think let me interrupt this procession. So here I suggest you when you are processing this data, you better connect par. So let me cancel it. And I think it's not work for now. Let's stop it. And open it. You can still use this method to clip the buildings. It will not take much time. But for the demonstration time, this time I will open it. Even there is building data, maybe you can say it is empty, so it did not succeed. For the time limits, I will just copy the one I imported it before, the buildings. This one, we can see there are only 600,000 data. Here I copy dataset to our it still needs some time. But for you, I suggest you just use clip to get your buildings. So for time limit, I don't demonstrate it again because it really costs time. So now we get the building data. The next we are going to clip the population data. Then we add the boundary of this region to the cut map. Here we are going to use the map clip method to clip the raster data, the population data. You select object area clip. First select the raster area and then right click it. And we remove raster. Here we store the population. We can add to cut. So here is the population and hospital and building is too large. So here we are going to create index, special index. And actually we found that because of the buildings are always a small area, so it's hard for us to know the whole building area. So here we are going to use this separate building to estimate the whole city's building area. Then the first we are going to convert the region building to point. Here we found conversion region to point. we use building, and here we building point. Now here we can add this point to count map. Then here we can see clearly of this building's distribution. And here I think we also need the cities layer. Administration tool and to current map. We extract the cities layer. Here we can open it, and the name one, we can see the name one Rashari. We can use the circle query to select where the name one equal Rashai, and we save the results as cities and the query. Here we can delete this one, and we add the city. So here we can see the city of Rashai, and let's change the styles of it. And then we can add the city names to the. We can know the points belongs which city. Much bigger. So here we can see the buildings mostly in Saragon, and the next is Rajai city. This is also hard to identify because they are the separate points. So we are going to use these points to get complete building error. So here we're going to use the aggregate points. We aggregate the building points. Here we set the radius. We can see it's much bigger. It means the points in the 2 kilometers. All points in the 2 kilometers can be composed a polygon. And here we building here. So here next. Okay. I suggest you when you when you are in procession, you better close this data in the map. I think it will be much faster. Here I just close these two layers. And then here we can see the building area. Here we can see the estimated building area. And also it totally is the same. So here we can know the urban area of the city. Then the most important is we are going to find the nearest hospital. Here we can see the hospital's points distribution. We are going to use this point to create a Tyson polygon. Hospital and hospital area can display in map. Okay. So here we can see. Let's put the point. Here we can see each hospital is in region, and in each regions the nearest hospital how to say, just like if you are in this area, your location is this area, and so this hospital is your best choice when you only consider the distance. So here it is the nearest hospital, and for this area, if you are in this area, and this hospital is the nearest one. So here we need to do some precision. We need to clip only this area's region. So here we can also use we put this recharge, and we selected maps. We use the map clip. Actually, the map clip can clip any region or any data set. So here we only keep hospital area here. We only need to clip this hospital area. Release Josh. Okay. And then we add this to count map. So we remove this one and put the hospital. So almost we can see the service area of each hospital with the nearest distance, and then here we finish the we finish the find the nearest hospital distribution, and then get the building area. Already get the building area, and then we are going to analyze the result. We can overlay all these layers. We just keep the layers we are useful. I think hospital point it is useful. We can change the layer style. We can find the hospital. Here we can use this one. And match. And then the hospital error, we can set a transparency. We use a light color and transparency. Here we don't use this error. We can overlay the building error. Here we can see in the city there are more hospitals, and we can also add the population distribution data. We can change the style of the. We change the range type. We select blue one. And the building error, we also change the type. Make the much beautiful and visible. Here we also need to, yes. So here we can get a result of this. We can see we can save the map first. This is a hospital. And save the workspace as BGD. Here we can see from this picture the hospitals in Russia are concentrated in the urban area, and sparse but uniform distribution outside the urban area. And the distance to hospital in non-urban areas is generally far, and the urban area has a large population, but hospitals are not so many. So maybe we can give some suggestions, just like we can increase the hospital construction in this area. And then let's also take a look at the hospital areas and the city now. Here we can only see the population, the relationship between the population and the building area. We can see that the population distribution and building areas are not reasonable. Here, just like the Rajshahi city has the most population, but building areas are limited. But Siragun has the largest building areas. And here we can see it. Here we can see the transportation of the layer. Here we can see the Siragun has the largest buildings, but the population are relatively less than Rajshahi city. And besides, just like the Bogra and Pabna, and also the Nogin cities are with more populations, but their building areas are especially small. So we also can see from this result that most cities of Rajshahi need to increase housing construction. So here we get two results from this vector analysis. The relationship between population distribution and building area, and the regionality analysis of nearest hospital distribution. And you can also output the results like this. Here we can see the regionality analysis of nearest hospital distribution. Here we can see the hospitals are concentrated in the urban area, and but the sparse and uniform distribution outside the urban area. And the distance to hospital in non-urban areas is generally far, and the urban area has large numbers of population, but hospitals are not many. And then next, we can also see the relationship between population distribution and building area. Let's get a summary of this course. In our summary, we just simply use the vector analysis to analyze the regionality of the nearest hospital distribution and the relationship between population distribution and building area. So here we can say we use the overlay analysis, spatial and the circle analysis, also the aggregation points methods to process the data. In this course, I wish you can submit work like this, the results of your analysis and description of your results. You can submit it to the Google Classroom. So I think that's all for today's course, and tomorrow we are going to continue to learn the raster analysis. So let's look forward to what the raster analysis can give us, raster analysis can give us. So see you tomorrow and have a good day. Thank you.